students. Hope you're all doing well, staying healthy, and ready for another geometry tutorial video here covering Unit 10. And today we're going to look at lesson number 6, dealing with secants, tangents, and angle measures. So again, last time we learned about a new segment called a tangent. A tangent touches the circle exactly once, only once, and then it veers off. And today we're going to talk about a new segment, and this segment is called a secant. A secant. So let's define a secant, and then we're going to go through some properties, a bunch of properties dealing with secants, and then how do they relate to the angle measures of an arc, of a circle, and so forth. So the intersection of a circle, intersections on or inside a circle. A secant is a line that intersects a circle in exactly 2 points. It intersects a circle in exactly 2 points. So you see some examples right over here. Here's secant J. Notice here is intersecting, it goes in the circle and then it comes out of the circle. So therefore it's called a secant. It goes in and then out. It touches the circle in 2 places, and hence it's called a secant. A tangent touches the circle once, a secant touches the circle twice. So, when 2 secants intersect inside a circle, the angles formed are related to the arcs they intercepted, or intercept. Let's look at the theorems that have to do with that. So when 2 secants intersect, they can intersect in really 3 different places here. Either A, they're going to intersect inside the circle like you see in theorem 10.2 here. Here we have 2 secants and they're intersecting inside the circle here. If that's the case, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angles in its vertical angle. So what we're saying here is that when these 2 secants come together and intersect inside the circle, that this measure of angle 1 here, this measure of angle 1 is 1/2 the sum of the 2 intercepted arcs, the one in front, so we have this intercepted arc, arc AB, the one in front, and the one in back, behind that angle, arc DC. So if I add those 2 arcs together and take half, I'll get the degree of angle 1. Same thing for 2. Angle 2 here would be, this angle right here would be 1/2 the measure of its 2 intercepted arcs, the one in front and the one behind it. So if I add these 2 arcs together and take half, I'll get the degree of angle 2. So that's the first theorem here, theorem 10.12. That's if the angle ends up inside the circle formed by 2 secants. And then the next one, theorem 10.13, is what if the angle ends up on the circle? If it's on the circle, if a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So here I have a tangent and a secant. They're intersecting on the circle, and this is 1/2 the measure of the intercepted arc, of its intercepted arc. So that angle 1 would be 1/2 the measure of arc BA, and angle 2 here would be 1/2 the measure of its intercepted arc, arc BCA. Pretty simple there. So let's use these theorems to kind of work through these 3 examples here, and hopefully you can get some activity questions here to be able to work on too. So number 1 here, you want to ask yourself first, is the angle inside, on, and then later on we're going to talk about outside. Well, in number 1, the angle here we're looking for is inside the circle, so I know it's 1/2 the measure of the intercepted arcs, the 2 intercepted arcs. So since I'm looking for angle 1 here, it's going to be the arc in front of it, so this intercepted arc, and then the arc behind it, which is right here. Those 2 arcs right there, the one in front, one behind it. So therefore I can write this down, that the measure of angle 1 is 1/2 to the sum of 52, which is the arc in front, which is the arc in front, and 40, which is the arc in back. Well, 1/2 the sum of 92 would be 46 degrees. So this angle right here is 46. Easy enough. All you have to really do at the end of the day is add them up and divide by 2. You just have to find the angles there, or the arcs. Now, number 2 here is a fun question because we work it a little bit backwards here. And number 1, you're given the 2 intercepted arcs and having to find the angle. And number 2, notice here I'm given an angle and an arc, and I'm having to find here the measure of arc GH of the arc now. So a little bit backwards here, but we're going to still use the same concept here. We know that that this angle here, which is 45 degrees, is 1/2 the measure of the sum of the 2 arcs, right? And so here are my 2 arcs. So if I add these 2 arcs and divide by 2, I'll get 45 degrees. And so that's what I wrote down here, that 45 is equal to 1/2 the measure of my arc I'm looking for this time, plus 28. That's the same thing as over here, except instead of looking for the angle, we're looking for the arc. So we're going to go ahead and just basically apply a little bit of algebra to this to find the degree of that arc. So I'm going to first double everything. I'm going to get rid of about 1/2 by multiplying both sides of the equation by 2. If I multiply this by 2, I get that arc GH plus 28. I'm going to double it and cancel this 1/2 out. And I'm going to double 45 and get 90. So I'm going to double everything. And then finally I'm just going to subtract. So I'm going to subtract 28 over there. And you will get 62 degrees is the degree of this arc. So it has to be 62 degrees. So there's that. So the first problem, we kind of worked it straightforward, add them up, divide by 2. And second problem, we worked it a little bit backwards. And if you look at the algebraic process here, we doubled and then subtracted. Instead of adding and dividing by 2, now we double and subtract. So the last one here, you notice here the angle I'm looking for, angle 3, is, where is it located? Yes, on the circle here, on the circle. So it's going to be 1/2 the measure of its intercepted arc, which is this right here. Notice how big that arc is, 220 degrees. And so all we're going to do here to find the measure of angle 3 here is take 1/2 of 220 degrees, and you get 110 degrees. Alright, so that's the conclusion to the first part of this lesson. What happens if an angle ends inside the circle? Well, it's 1/2 the sum of the intercepted arcs. What happens if the angle ends up on the circle? Well, it's just 1/2 of that intercepted arc. And then in the last part, oh, we got one more here, sorry. Moving too far ahead of myself. So here's another example of where we have to find arc RT. And you notice here what's given to us is the angle on the circle. And so if that's the case, then that arc should be twice as big as that angle there, because the angle should be half the size of the arc. So let's see if I can do it. So that arc RT is equal to of that angle. This arc is twice as big as the angle here. Well, we know the angle is 74 degrees. So arc RT is 2 times 74, which gives us 148 degrees. Alright, so if it's on the circle, then the angle is half the measure of the arc. So what happens in our last situation, not only can I have an angle inside the circle, I could have an angle on the circle, but I could also have an angle outside the circle as well. So we have another theorem, theorem 10.4. What happens if the angle is outside? Well, if two secants, a secant and a tangent, or two tangents intersect the exterior, this is the key, the exterior of a circle, then the measure of the angle formed is 1/2, again, the difference of the intercepted arcs, the measure of the intercepted arcs. So instead of 1/2 the sum, it's 1/2 the difference. So for instance, I have 3 scenarios here. I have, these are 2 secants here. 2 secants. So this angle A here is 1/2 the difference of arc DE minus BC. And it's important that you put them in order here. It's always the outside, the outer arc minus the inner arc, inside arc. So if I look at the next one here, the next one, a little different scenario. We have a secant, this line here, AD is a secant, and then you have this line right here, which is a tangent, but the angle is still outside, so it's 1/2 the difference, and the difference is DC minus BC, the outer intercepted arc minus the inner intercepted arc. And then we have one more scenario here. We have 2 tangents here. Both of these lines are 2 tangents, and it's still, this angle here is 1/2 the difference of the outside arc minus the inside arc. Arc BDC minus arc BC here, as they said here. So it's always the outer arc minus the inner arc. The outer arc minus the inner arc. The outer arc minus the inside arc. Alright guys, so let's look at a few examples where we're going to have to find the degree of the angle or the degree of an arc using this. All these examples here, the angle ends up outside, like in number 1, straightforward example. And so to find angle 1 here, we're going to use that theorem 10-4 again. And we know that this angle is equal to 1/2 the measure of the outside arc, here's the outer arc, minus the inside arc, the inside arc. And so in this case, it'd be 1/2 of arc SV minus arc TP, or 1/2 of 80 minus 40. Well, 1/2 of 80 minus 40, 80 minus 40 gives me 40. So if we take half of 40 now, I get 20 degrees for this angle. So I know that this angle right here is 20 degrees. Pretty cool. I hope you think so. Alright, let's look at another example. In this example here, we're working backwards again. So instead of looking for this angle, now actually we're looking for the angle again. But, sorry, I didn't really look at it. But we're given different lines here. Here's a secant and a tangent, but the concept's still the same. The measure of angle 2 here is going to be 1/2 of the outer arc. Now this is your outer arc, the one furthest away between X and Y. So here's our outside arc, minus the inside arc, which is this arc right here. So that's 160 and 80 here is what I'm looking at. So angle 2 is equal to 1/2 of arc XY minus YW. And we know that that's 160 minus 80. And 160 minus 80 gives me 80. And work it out. And then 1/2 of 80 is 40 degrees. So this angle right here is 40 degrees. Alright, let's look at the next couple here. Example 3 here. A little bit different. This is the tangent. Given tangent, but the concept's still the same. Is always the outside arc. That angle 3 is the outside arc. In this case, the major arc there minus the inside arc, the inside. And so you know the outside arc here is 220 degrees. But the question is, how big is that inside arc? So angle 3 is 1/2 of 220 minus whatever this inside arc. Do you think how do you think we're going to find that arc right there? What are we going to do to get the degree of that? If I just know that the outside arc is 220, do you see? Yeah, of course. The whole circle here is 360, correct? Well, if I know the whole circle is 360 and one major arc is 220, if I take 220 away from 360, what am I left with? But 140 degrees here for this arc there, I believe. And so there is that arc right there. So the measure of angle 3 is 1/2 of 220 minus 140. Well, what's the difference between 220 minus 140? Let's think about that. The difference between that will be 80 degrees. 80 degrees. So 1/2 of 80 degrees gives me 40. So I know this is 40 degrees here. Alright, I believe we have one more problem here. Now we'll work it a little bit backwards here. Given the angle here in one of the arcs, can I find this second arc with that information? So we're going to work it a little bit backwards, but the form is still the same. We're still using that same theorem, that this angle here, angle R in this case, is equal to 1/2 the difference of 70 minus the inside arc, which is what I'm looking for, JP. So we're going to write that down here. So angle R is 1/2 of KM, which is that outside arc, minus JP. And so let's put in our information here. We know that angle R is 20 degrees. We know we have 1/2, KM is 70, looking for JM. So think about it for a moment here. When we were working out these problems, first we took their difference, right? And then we took 1/2 of it. So what do you assume I'm going to do now here for this problem here? And I'm going to work it backwards. So instead of doing 1/2, we're going to double the whole thing, just like we did on the last one. Kind of the second example, I believe, in this lesson. So we're going to double this whole thing. We're going to get rid of 1/2 by doubling everything. Multiply that by 2, and multiply 20 by 2, you get 40. And so if I double the whole thing, I get 40 equals 70 minus JP. And then we want to, here, we're going to have to subtract 70, I believe. I think that's what I did here. So if I subtract 70, I get 40 minus 70, which is negative 30. But that's equal to negative arc, negative arc JP. And then you got to divide by negative, or just make it positive because two negatives here. So therefore, arc JP is 30 degrees. And there you go. And if you wanted to kind of check your work here, if I take their difference, if I take 70 minus 30, that's 40, take 1/2 of it, and you get 20 degrees, and it works out. And so that's the conclusion here. Let's summarize it here. So if the angle is inside the circle, then it's 1/2 the sum of the arcs. If the angle formed by the two lines is on the circle, then it's simply 1/2 of the arc. And then finally, if the angle is outside the circle, on the exterior of the circle, then it's 1/2 the difference of the arcs. And so that's what I've been trying to teach you today, and we worked out a bunch of examples. There's some activity questions there for you to do online. If you'll get those complete, submit those to me. And then stay healthy, love your family, and I'll see you on the other side.